This module, you will study about characteristics of musical sound. We hear different kinds of sounds. We hear the sounds of vehicles, the sound of the market, the sound of rainfall, the sound of musical instruments, etc. every day. Some of these sounds are sweet and some are harsh. If we judge by our sensation, the sweet sounds are musical sounds and the others are called noise. Musical sound is a tone with characteristics such as controlled pitch and timbre. Musical sounds are distinguished from noises in that they are composed of regular uniform vibrations, while noises are irregular and disordered vibrations. Now, here we have a set of differences between musical waveform and noise waveform. Musical waveform is a periodic disturbance which repeats at regular intervals of time, whereas noise is a non-periodic disturbance. In musical waveform, there is no sudden change in amplitude or loudness, whereas in noise waveform, there are very often regular sudden changes in amplitude or loudness or both. Musical waveform, it is a sufficiently rapid so that it can be ensured as a sense of continuity. There is no sense of continuity in the noise. Here you have graphical representation which indicates the difference between the musical waveform and the noise waveform. And if you will observe in the first graph, here you can see there is no changes in the amplitude. It is very periodic. Here it is all haphazard. It is not even periodic, neither, and there are abrupt changes in the amplitude. You can see the difference in the peaks over here, whereas over here the amplitude remains the same. One musical tone is distinguished from another on the basis of pitch, loudness or intensity, and quality or timbre. These are the three characteristics of musical sounds. Let's talk about the first characteristic of sound, that is pitch. Now, pitch is that characteristic of sound due to which we are able to distinguish between a shrill sound and a hoarse or flat sound. So we can say pitch means shrillness of sound. Shriller the sound, higher is the pitch. From our daily experience, we are aware that child's voice is shriller than that of an old person. Woman's voice is shriller than that of a man. Sound of buzzing bee has a higher pitch than a roar of a lion. In a music system, the terms bass and treble refer to low pitch and high pitch respectively. At bass, low pitch sounds become predominant, but at treble, high pitch sound becomes predominant. The sensation of shrillness produced by a note is known as pitch. It is the sensation conveyed to the brain by the sound waves falling on the ears. This sensation depends directly on the fundamental frequency of incident sound waves. Greater the frequency of a musical note, higher is the pitch. That means frequency and pitch are related. Pitch is directly proportional to the frequency. Now see this graph over here. You can see waves, different waves, right? But each wave has a different frequency. So the wave with less frequency will have less pitch, whereas the wave with more frequency, this is a wave which is having maximum frequency. So this will have higher pitch, whereas this wave has a very low frequency. So obviously it will have low pitch. Now just see over here. This is again graphs, two graphs which are indicating the waves. Over here, we always mark the displacement of the particles, and this is the distance over here. This is the time taken by the wave to propagate. So what is so obvious to you? You can obviously see that this is having less frequency, isn't it? And this is having more frequency. Obviously, since this is having more frequency, this will be high pitched. So, as higher frequency sound has a higher pitch and a lower frequency sound has a lower pitch. So, in the first graph, sound has a lower pitch. Whereas in the second graph, the sound will have higher pitch. For instance, the chirp of a bird would have a high pitch, but the roar of a lion would have a low pitch. Although the pitch is directly related to frequency, but they're different. I mean, if we have to talk about the pitch, we do say that it depends upon frequency. More frequency, more pitch. But still, pitch and frequency are two different things. The frequency of note is a physical quantity and can be measured accurately. You know, frequency is number of vibrations made in 1 second. On the other hand, pitch of a note is merely the sensation experienced by the listener, right? You might find a person's voice shrill and someone else may not find it to be that shrill. So it's simply a sensation that you feel. Thus, frequency is a physical quantity, that is, a measurable quantity, whereas pitch is a physiological quantity, that is, just a sensation. The second characteristic of musical sound is loudness. It is that characteristic of a sound due to which loud or intense sound may be distinguished from a soft, weak sound. So, loudness refers to how loud or soft a sound seems to a listener. The loudness of sound is determined in turn by intensity or amount of energy in sound waves. The unit of intensity is decibel. The symbol you can observe over here is written as dB. As decibel levels get higher, sound waves have greater intensity and sounds are louder. Now, let's see what are the factors affecting the intensity of sound. First is amplitude of vibrations, distance of listener from source, surface area of vibrating body, density of medium, presence of resonant bodies. Let's discuss them one by one. There is amplitude of vibration. What is amplitude? Amplitude is maximum displacement from the mean position. Now, intensity of sound produced by vibrating body is directly proportional to the square of its amplitude. That is, mathematically, I is directly proportional to A square. When an object vibrates with a greater amplitude, it emits a greater amount of energy, and hence sound intensity is more. Here you can observe two graphs showing two waves. Now, the difference between them is of amplitude. The first wave is having smaller amplitude than the second wave. Since the second wave's amplitude is large, the loudness of this particular wave will be more than the loudness of this wave. You can even compare the amplitudes of two waves by using the relationship I1 upon I2 is equal to A1 square upon A2 square, where I1 is the intensity of the first wave and A1 is the amplitude of that wave. Similarly, I2 is the intensity of the second wave and A2 is the amplitude of that second wave. Now, suppose if you know that the intensity, suppose we say that the ratio of intensity I1 upon I2 is equal to 4 upon 9, and you are asked to find the ratio of the amplitudes. Then you know that I1 upon I2 is equal to A1 square upon A2 square. So what will be the ratio of amplitudes? A1 upon A2 will be equal to 2 by 3. The next factor on which the intensity depends is distance from the source. Intensity of sound is inversely proportional to the square of distance between listener and source of sound. That is, mathematically, I is directly proportional to 1 upon r square, where r is the distance between the listener and the source. As one goes further from source, intensity of sound becomes less intense. Over here, you can observe that there is a source of sound. There is a listener which is at a distance of 10 meter, whereas there is another listener at a distance of 1000 meter. Now, the intensity of the sound heard by this listener is 80 decibel. Can you find the intensity of this listener? Obviously, try it out. You can use the relationship over here I1 upon I2 is equal to R2 square upon R1 square. So, what will you have? I1 is 80 decibel upon I2. We need to calculate. This is equal to R2. What is the distance R2? 1000 square upon 10 square, right? So what do you get? I2 is equal to 80 into 10 into 10 upon 1000 into 1000, right? This gives you 8 upon 1000 decibel. So just see how less the intensity of sound will become when a person is very far off. This is the reason when you stand in the assembly, then the students who are in the front are able to hear the words spoken by the speaker loud enough. But the same intensity of sound is not heard by the people or the children who are at the end. Third factor is surface area of vibrating object. If surface area of vibrating object is more, then intensity of sound is also more, as it will provide more energy. Mathematically, I is directly proportional to A that is surface area. It is due to this reason sound produced by a big sized drum is louder than the sound produced by a small drum. No doubt, when you go for PT in the open field, then you prefer a drum with a large surface area so that the sound is loud enough for everyone to be heard. Then is the density of the medium. If the density of the medium between the source of sound and listener is higher, the intensity of sound is more. The intensity of sound is directly proportional to the density of the medium between the source and listener. Another factor is presence of resonant objects. If some resonant objects are present near the vibrating object, then due to resonance phenomenon, the amplitude of vibration and hence intensity of sound increases. Here we have differences between loudness and intensity of sound. Like frequency and pitch were two different quantities, similarly is the case with loudness and intensity. Loudness is simply a sensation, whereas intensity is a measurable quantity. So we can say loudness is a subjective quantity. It depends upon the sensitivity of the human ear. A sound may be loud for a person, but the same sound may be feeble for another who is hard of hearing. Whereas intensity of sound is an objective physical quantity. It does not depend on the sensitivity of a human ear. Secondly, loudness cannot be measured as a physical quantity because it is just sensation which can be felt only, whereas intensity of sound can be measured as a physical quantity. Now, observe this. There are two waves, one shown in orange color and the other shown in purple color. What is common between the two? And what is the difference between the two? So, what can you observe and say about the wave? Well, you can say that the amplitude of two waves is the same, but frequency is different. So, what will that result into? So, the purple wave will have more pitch than the orange wave because the frequency of purple wave is more than the orange wave. So here remember that even when the two waves have same amplitude, the pitch is different because of the difference in frequencies. Here again you will observe two waves, a blue and a orange wave. Now over here, if you observe, the wavelength of both the waves is identical, isn't it? The wavelength is the same. Then what is the difference between the two waves? The difference is of amplitude. The blue wave amplitude is less and the orange wave amplitude is more. So the difference in the two waves will be in their loudness. Less amplitude means less loud, more amplitude means a louder wave. So the red wave represents a louder sound than the blue wave because it has higher amplitude. Third characteristic of the musical sound is quality or timbre. The quality of sound is called timbre of sound. The quality of a musical note is that property which enables us to distinguish it from another note of the same pitch and loudness. It is determined by the number of harmonics present, their order, and relative intensities. Every sound that we hear is dependent on its source. Sound timbre is defined by the characteristic sound wave form, which is dependent on the material through which it is produced. Because of timbre, the sound of flute and harmonium or other musical instruments can be differentiated. For example, the frequency of a particular note like re or sa produced by all musical instruments is same. In spite of this, because of different timbre, one can differentiate the sound of same frequency of different musical instruments. You can very easily tell whether it is being a harmonium played or a sitar being played or a guitar being played because the sound comes from different musical instruments. They have their own particular characteristic. Now, even when you pick up a phone and you hear someone speaking known to you, you can very easily tell that this is so and so person, even if the person doesn't identify himself. Why? Because different persons produce different sound of different timbre because of the different timbre in sound. The voice of different persons can be recognized without even looking at the person. You can easily identify who is speaking because each sound is different. What is timbre actually? Any sound that you hear is consisting of more than one frequencies, and most of these additional frequencies are known as harmonics. There will be a fundamental frequency and additional frequencies. Additional frequencies are known as harmonics. The fundamental frequency is the lowest frequency waveform, which is known as pitch of the note in music. For any sound to possess timbre, it must have one fundamental frequency and seven or more additional harmonics. That is, for any sound to be identifiable, the sound must have one fundamental frequency and seven additional harmonics. And if any sound which doesn't possess these won't be identified by the human ear. Here is a picture explaining different types of waveforms that give an idea of how timbre appears. So you can see that there are four different things: a tunic fork, a flute, voice of a person, and a violin. So a tunic fork you can find is having only a single note, and then you can see that different voices may be saying having same pitch and amplitude are different due to different wave forms. Tone and note of sound. Sound of single frequency is called tone, and sound of mixture of several frequencies is called note. A note is always pleasant to listen. We can summarize the characteristics of sound in this small setup. So here you have the characteristics of sound 3: loudness, pitch, quality or timbre. Loudness depends on amplitude of vibration, and here is a graph distinction between two sounds on the basis of amplitude. Less amplitude, soft sound; more amplitude, loud sound. Pitch depends on frequency, and the graph is indicating the difference in frequency. Less frequency, that means low pitch; more frequency, that means high pitch. Then it is quality, which depends upon waveform. Here, this is a two waveforms with difference, this thing. Rather, like you can have a wave of this kind with same amplitude but with waveforms over there. So these are the three characteristics of the musical sound. Remember, loudness, pitch, quality. Loudness depending on amplitude, pitch on frequency, and quality depends on waveform. And this is how you can distinguish between all the sounds that you hear around you.